Hey folks, this particular lesson is about, it has to do with trigonometry, even though it doesn't seem like trigonometry. It will eventually, because yes, there will be triangles eventually. But for now, what we're going to focus on is angles in standard position, which is a strange sort of new thing that you've never maybe seen that you've never maybe seen. It's for angles between 0 and 360 degrees. So when you see an angle in this so-called standard position, imagine that this is the 0 degrees or the starting point. And normally on a clock you would go this way around, right? You would go like this around on a clock. That's not true here. With angles in standard position, let's say if you had 30 degrees, you would move upwards from there. So you'd go up there and you'd write 30 degrees, okay? Later on, we'll make a triangle out of this like this, and that's where trigonometry will get involved. But for now, what you have to know is that we're going to be moving counterclockwise, okay? So between 0 and if you end up all the way back there again, it's 360 degrees, okay? If you were to keep going like 720 degrees and etc., like snowboarders in the Olympics doing jumps, that is something else. That's just, you'll end up in the same position. But today we're just going to focus between 0 and 360 degrees. Okay, so there's some words you're supposed to know. The initial arm is this arm right here. You can see the diagram right here. The terminal arm is where you end up. So once again, if someone gives you an angle of 60 degrees, you could write it like this. This over here would be your terminal arm. Okay? I don't know if it's worth me writing this out. I'll just say terminal arm. Maybe I won't say it each time. But that's called the terminal arm. Okay? If somebody gave you an angle of 150 degrees, where would that be? Well, here's 0. Over here is 90 degrees. Over here is 180 degrees. And over here, in case you don't know it, you probably do, it's 270 degrees. Okay, so if someone said 150 degrees, it would be somewhere in here. Okay, and this between here and here, this angle that went from here to here, from the initial arm to the terminal arm, okay, would be 150 degrees. Okay, pretty strange stuff. If someone said 300 degrees, where would that be? Well, it would be somewhere in here, right? 300 degrees would be beyond 270, so it would be like somewhere close to the, up to somewhere close around here. I'm not going to draw it in just because I'm taking too much of your time. Okay. Do you already know quadrants? Well, if you don't, it's just a reminder that this is called quadrant 1. And as you move counterclockwise, this is called quadrant 2. This is called quadrant 3, and they usually write it with Roman numerals like this. Luckily, you don't have to keep going much further than this because there's only 4 quadrants. Okay? So, those are the quadrants. So, let's do one more thing. If you had an angle of 200 degrees, what quadrant would you be in? 200 degrees would be what quadrant? You should tell me quadrant 3. All right? Let's keep going here. Now, I'm not even sure if we need these diagrams, but I can tell you that the principal angle is the angle that we are told. This angle right here is our principal angle. Okay, here's our principal angle. I'm going to put it in pink each time. This is our principal angle. It's the angle that we are told to jot down. Principal angle in this case, I would go all the way around this way, like that. Okay? So, yes, you can have negative, like if you said, let's say you said negative 30 degrees, you would go this direction. But in this particular course that you're taking, we're just going to be dealing with positive degrees. So instead of negative 30 degrees down here, we would probably say 330 degrees. It would be our principal angle. Okay? The principal angle has another angle that's related to it. It's called the related acute angle. What that means, and this is the tricky part, what that means is that you get an angle that, this is it right here. It's the angle. Now, by the way, the principal angle and the related acute angle are the same thing in quadrant number 1. Okay, but in this one, the principal angle, let's say let's just make this up. Let's say this was 150 degrees. What would the related acute angle be? So we're going to make a little triangle here. Here's our little triangle. And this angle in here, what would that be? Well, you know that 180 all the way from here to here is 180. So 180, and if you subtract 150, you're left with this. And here, that would be 30 degrees right there. Our related acute angle would be 30. So the related acute angle is the angle between the terminal arm, this is called the terminal arm here, okay, and the x-axis, not the y-axis. It's never this axis here. It's always this axis here, okay? So the angle right here is our related acute angle, okay? So in this case, let's say this was 330 degrees would be our principal angle. What would the related acute angle be right here? Remember, we're making a little triangle here. It goes up to the x-axis. It's always the x-axis, okay, that's used. What would this angle be right here? What would this angle be right here? Well, that would be called, well, first of all, it would be 30 degrees. That would be 30 degrees in there. And it's also called our related acute angle. Sometimes they say RAA, related acute angle. Okay? It becomes important because we're going to be using trig functions and trig ratios on these types of little triangles that we draw when we do this stuff. It's actually kind of fun, but in the beginning, I know it looks a little crazy. Okay? Now, the last thing this video is going to talk about, instead of getting too detailed about anything, well, you already know quadrants, but if you took a calculator right now, and we're going to do a little bit of trigonometry here, everything between here and here is between 0 and 90 degrees, okay? 0 to 90 degrees. If you took your calculator and typed in sine 80, what would you get? Would your answer be positive or negative? Well, if you do this on a calculator right now, and if your calculator's in degree mode, you could tell me whether this is a positive or a negative result. Well, if you do it, you should get positive. In fact, no matter if you use sine, cosine, or tangent, no matter which one you use, anything between 0 and 90 degrees is going to be positive. Okay? And that's where the A comes from. The A means that all of them will be positive. Sine, cosine, and tangent between 0 and 90 degrees, you will get a positive answer. Okay? If you go beyond 90, and you go between 90 and 180 degrees, I'm actually going to put that in a different color. Okay? Anything between 90 and 180 degrees, if you do that on your calculator, you will find that there's only one of these three that will be positive. Okay? Can you guess based on the S right there? Can you guess which one's going to be positive? Well, if you guess sine, you are correct, and you can check it on your calculator. If you were to type in sine 100 in your calculator, you would get a positive answer. Okay? But if you were to type in cos 100, you would get a negative answer. Same with tan. If you did tan 100, you would get a negative answer. Only sine is positive in the second quadrant, and that's why the S is there. Okay? So only sine. Now, you can probably guess the T and the C. Only tangent is going to be positive with a degree between 180 and 270. So if you typed in tan 200, you would get a positive answer. But if you typed in sine 200, you would get negative, and same with cosine 200, you would get a negative answer. Over here, you can guess it's cosine. Cosine's going to be positive between 270 degrees and 360 degrees. Okay, anywhere between those two, you're going to get cosine being positive, but sine and tangent are going to be negative. So someone changed or helped people remember this, and they called it the cast rule. The cast rule is just a way to remember that C-A-S-T, that cosine's positive in the fourth quadrant, all of them are positive in the first quadrant, sine is positive in the second, and tangent's positive in the third. For now, that's all you need to know. But we are going to, of course, use all of this information as we get a little bit more familiar with this. This is just an introduction, so I'm going to stop there, and feel free to watch the next video. And I even not sure if I can remember what it's called. I think it has to do with finding two places on the quadrant where a trig ratio would be the same. But that sounds confusing to you. Why even talk about it? I'll let you look at the video on your own time. Take care. Bye.